Alright, let's talk about the turning effect of forces, assignment 1 now. Okay, so for the first question, they asked to define the moment of a force. Alright, so again, this can be found in the booklet. I'm not going to go through the definition, but just something that I want to emphasize. We need to talk about product of the force, alright, and not just the distance between the pivot and the force. Alright, you need to talk about the perpendicular distance. Okay, this is very important. Okay, something that I just want to highlight. State the SI unit. SI, right? Because it's a product, right? Multiply your force and your distance. So therefore, Newton is the force, distance is meter, Newton meter is the SI unit. State the full formula used to calculate the moment of a force. The papers that I've marked, many of you actually managed to give me the formula, but not the full formula. Alright, so in this case, the 2 mark one is from the correct formula, the other one is actually spelling the entire thing out. Okay, so again, that one is found in the booklet. I'm going to leave that to you. So maybe I already how spell out in full. Alright, I think I actually wrote that as your feedback on your papers as well. State the 2 types of moments. Well, 2 types, I see this as more of 2 different direction of moment, right? So we have the clockwise moment and the anti-clockwise moment. Okay, spell them out, please. Question 2. It says a uniform beam. Uniform, remember what we said about uniform? Okay, it means that the weight of the beam will act right in the middle. Okay, it's pivoted at its midpoint. So middle so the weight is here. So since the weight and the pivot is at the same point, the weight of the beam will not affect or cause or create any moment, okay, around the pivot, since the perpendicular distance between the force and the pivot is 0. An object is placed at the beam, on the beam as shown. They ask we all to calculate the moment of the object about the pivot. So, right, so moment equals to, so we have 40 Newton force times distance. Take note the distance is in centimeter. So if you're going to do this, answer will be 800 Newton cm. Alright, so if you actually happily just assume the answer will be written in SI unit and you put 800 Newton meter, I'm so sorry, you're going to get it wrong. So remember, moment also has direction. So please, you need to write this in. This is anti-clockwise moment. Okay, spell it out. So can you leave your answer? Can you leave your answer in what is that called? Newton meter. Of course we can. Alright, so another way to look at it is moment equals to 40. Then we just have to convert the distance to meter. Alright, so 40 multiplied by, in this case, 0.2, 8 Newton meter. Anti-clockwise moment. Okay, either one. Question 3. In each of the following diagrams, calculate the moment exerted about the pivot when the force acts at a point shown. So indicate also whether the moment is clockwise or anti-clockwise. This is so nice, they tell you. Alright, so if they tell you and you still don't do it, I really have no idea how else you want us to request the direction from you. Okay, so A, this is the direction, anti-clockwise. Write it down first. So M moment equals to, again, 5 times 30. Okay, I'm going to emphasize again, the question did not ask us to express the answer in SI unit. So therefore, there is no need to express in SI unit. Okay, we need to be very clear, observe what we have, read the question carefully, and give the question what they want. Okay, because a wrong unit may give the wrong unit basically means very different values. Okay, so I get 150 Newton cm anti-clockwise moment. Can you do it in terms of Newton meter? You can, but I'm going to leave that to you. Alright, the way to do it is the same as this. You just have to convert your distance to meter by dividing cm by 100. B, moment equals to 20 times 20, I get 400 Newton cm. So what's the direction here? Clockwise moment. C, moment equals to 8 times 50. This is also 400, is it? 8 times 50, is it 400? Yeah, okay. So, but the thing is, The direction, okay, is acting on the right hand side but it's not coming down. Instead of pushing it down, I'm actually pulling it up. So this is the direction that we're talking about. So what direction is this? Anti-clockwise movement. Okay, 6 marks. Question 4. A student conducts the following experiment to feel the turning effect of a force as shown in the figure below. So he's holding on here. So this is like a pivot, right? Because if anything is going to happen to this, this entire setup, all right, this thing will actually move in this direction. Now, how is this ruler being held horizontally? Is because over at this side of the hand, you actually press it down like that. Then you create an anti-clockwise moment. And when these two moments are equal, the ruler will actually be held horizontal, right? So A, they say the weight W is placed at 15 cm mark as shown. Okay, here. Determine the moment of a force of the force about the pivot. So moment equals to what? Force times distance. The distance is not 15 Alright, this is the most common mistake that we see from the students. Alright, we need to talk about it's a 15 cm mark. They did not say it's 15 cm from the pivot. So we need to 40 minus 15. What is that? It's 25, right? So 5 times 25, I get 125 Newton cm. What is the moment? Direction? Clockwise moment. He then shifts the same weight W to the 5 cm mark now. To the 5 cm mark. Oh, okay. So basically, if this is 15, this is 0. 5 must be here, right? So now the weight is here. 5 Newton is here. Okay. So this is my new distance. What's the distance now? Instead of 25, now it's 35 cm, right? So they say he finds it more difficult now to maintain the half-meter rule in a horizontal position than before in part A. Explain why this is so. Alright, so let's find out, okay? Explain why this is so. They never say you show working, or they also never say you don't have to show working. So let's use the working to explain. We use numbers to prove. Alright, it's easier to visualize numbers, right? So what is the new moment? New moment. Alright, new moment will be 5 Newton multiplied by 35 cm, right? So what do we have? 5 times 35, 175 Newton cm. Clockwise moment. So the moment is now larger, okay? Since a larger moment is created by the weight, comma, then what happens? It means that my counter moment, my anti-clockwise moment must be larger also, right? Larger, and anti-clockwise moment is needed to balance the ruler. So you see, okay, distance, or rather perpendicular distance, okay, perpendicular distance for hand did not change. Alright, so what does that mean? It means a larger force is needed. Okay, so this is the important part. Alright, you need to understand that, okay, it's because when the weight is moved further away, a larger moment is generated by the weight. So you also need to have a larger moment, right, to counter the ruler. So since the distance is constant, the only way to create a larger moment is you need to exert a larger force. Okay, so this is proving by number. But if you don't want to prove by number, then you just have to say, since the perpendicular distance between the weight, alright, between the weight and the pivot is now increased, a larger clockwise moment is generated. Then, same thing, you don't have to show the 175 Newton cm, you just have to tell them that larger, because of the increase in perpendicular distance, a larger clockwise moment is generated. Okay, so therefore, then you continue from here again. It's the same part. Okay, big word, yes. Question 5, explain why the turning effect of the 10 Newton force about pivot O is 50 Newton meter. So this is a 2 marks question. Alright, so we need to tell them why 50. Okay, so how do you even get 50? We need to tell them that the perpendicular distance is 5 meters. Right, you see, you extend the line of action. This is the perpendicular distance, right? So this is 1 mark. The second mark, you show them 5 times 10 equals to 15 Newton meter. Alright, because the question in nowhere in the diagram shows you that the moment is 50 Newton meter. So you need to show them how 50 is gotten. It's actually to the product of 5 and 10. Question 6, explain why the turning effect of the 10 Newton force about the pivot O is 0. Why? Because it's acting in this direction, right? So you need to tell me that the perpendicular distance is 0. How? You see, because there's no perpendicular distance, right? Alright, there is no perpendicular distance, therefore 0 times 10 equals to 0 Newton meter. Okay? Question 7, explain why the turning effect of the 10 Newton force. So you see, it's very repetitive. So 10 Newton force is like that. You see, extend. So what's the perpendicular distance? This is the perpendicular distance, right? So perpendicular distance is 3 meters. So 10 times 3, 30 Newton meter. Oh, I forgot one thing. Alright, we don't have to show the direction here. Okay? Because the question is asking you to verify or to prove the number, I mean the magnitude. Alright? The direction is not required. Okay, so if you want to put it in, you can, but there is no need to. Alright? So that marks the end of tutorial 1.